Okay, so I will start my today's system design practice. Okay, so today's topic is this one, design Twitter feed. Oh, I'm sharing my screen. Oh, yeah, okay. So yeah, let me talk about this topic today. So let me start with the functional requirement. And for writing the functional requirement, let me write the UI quickly so that I can imagine the, I can consolidate the functional requirement with the solid image in my head. Okay, so basically, when I talk about the Twitter feed, what I have in my mind is like this. So basically, I can tweet something here. Yeah, so I can input the sentences, then I can push a tweet button and the tweet is, posted. And then also, I mean, when I post my tweet, I can see the tweet here in the feed. So this is exactly the, Twitter feed. So I can see the list of tweet, post. Yeah. And the post is from the, I can see the list of followed users. Users followed by me. So yeah, basically this is the basic understanding of my, basic understanding of the Twitter feed. So let me write the function requirement with this idea. So basically user can post the tweet and also user can follow other users and user can see the list of tweet he okay, and being more specific. Okay, yeah, the should definitely the signing and sign feature, and also the thing I'd like to clarify is if user can post the images or not, or how many characters can be at max, how many characters the 10 sentences, the tweet can be, or something like that. So let me think. Okay, so basically, I will set as define the max limit of number of characters to be 140, and also user can attach image. Okay, let me define it as, attach up to 4 images to one tweet. Yeah, let me go with this definition, specification, and also, in the Twitter in the real world, user can block other users or unblock other users after blocking. But let me omit that feature and let me focus on the Twitter feed feature only. Yeah, in the system design. And okay. Good. So that being said, oh, one more thing. So so I will not talk about this one, signing or sign up feature in this system design. And also here, the post are sorted by the, I mean, yeah. So, oh, new one first. Okay. So, and also let me say, the post is sorted by the tweet date time. So the latest tweet is, on the top. And as I scroll down, I can see, yeah, many new feed. I mean, many older tweet. Yeah, in a, yeah, I mean, older way. Okay. And also, see, I think one more thing, which is kind of necessary, or I should say, user-friendly feature I can say is when I keep open the and keep this Twitter feed page open, I can see the new tweet, number of new tweet. So if I keep waiting for this, I can see like 12 new tweet or something like that. Yeah. And if I click this, yeah, I mean, kind of big button, the new Twitter, loaded into the top of the feed. That's another thing I think, yeah, which is valuable. So yeah, basic. So let me, yeah, decide the specification by myself on this. So the post is updated every 10 seconds or less. Yeah. Let me, okay, on the second thought, let me discuss on that frequency later. So first here, let me just say, new tweet are loaded automatically. Yeah. Okay. So this is a basically functional requirement of the Twitter feed. So now I will talk about the non-functional requirement. So firstly, what I can say is, so just say about kind of consistency. Oh, let me think. Yeah. So for the consistency, I think eventual consistency is fine for this Twitter feature. So yeah, basically, I think some of the tweets do not appear as soon as, I mean, first, but say later. Okay, even if the new tweet doesn't appear on the pod on the feed, I think I can accept it. I think if the post appears, say, after 1 minute, it is totally fine for Twitter feed. Yeah. So in that sense, let me say, I need the eventual consistency in this Twitter feed. Oh, and let me add something here. So basically, one thing I forgot to say is the user can reply to the post. Yeah. Yeah. I will omit this feature in this discussion, but when it comes to this one, reply feature, the consistency, a stronger consistency is required because I I want to avoid the situation that there is a thread of the conversation of the replies. And the first one is there, but the second one doesn't appear, but third one appears. So in that case, because the second one is skipped, the conversation doesn't make sense for the users. So for that thread, I'd like to guarantee the strong consistency. Yeah. Okay. So let me think of other, functional requirements. So for the scalability, yeah, I will talk about this, but I will assume that, yeah, there's some famous users, celebrities, like Taylor Swift or, yeah, Ed Sheeran. I mean, what I mean by that is such users have very so many followers. Yeah, so that's one thing I'd like to handle in this, yeah, system design. Oh, and also I would say, let me just clarify that this system is read heavy. So I'd like to keep this in my mind. So yeah, because probably many users open the Twitter and see the post. Yeah, I mean, they spend most of the time reading the tweet from others. And sometimes they tweet, but probably I can say read versus read to write ratio is 10:1 or something. Yeah. Okay. And let me see. Let me quickly think if there is a spike or not. Yeah, I think it is possible that some people say, let's think that on the New Year's Day, or maybe Christmas, on the Christmas day, probably on the 0 a.m. on the day, many people tweet like Merry Christmas or Happy New Year. So that can be the spike of the right operations. Yeah. That another thing is how I'd like to handle in the system design. Okay. And availability. Yeah. So okay, so availability. I'd like to, yeah. I don't want this Twitter application to be down because of some of the feature. I mean, some of the system error. So I would say, oh, yeah, yeah. But basically, I'd like to system to keep running. Say when for example, if the payment system goes down, so yeah, that's another thing I'd want to, yeah, keep in mind. And also durability perspective, let me say, yeah, I don't wanna lose tweet recalls. Yeah. So I wouldn't say the durability required for Twitter is not as much as, say, banking system. I mean, for the banking system, they wouldn't like to lose any record. However, for Twitter, it is still acceptable that, say, the past 1 minute latest tweet is lost because of the failure. Yeah. In the user experience perspective, it should be definitely avoided, but still acceptable compared with the banking system, I think. Yeah. Okay. Yeah. This is the thing oh. Yeah, the performance, I think. Yeah, this should be basic. Yeah, probably I want the operation to be finished in 100 millisec for posting or fetching the pages. Yeah. Okay. Yep. And maybe some authentication should work fine. And also maybe I try to avoid the DDoS attack. Yeah, these are the things that I want the system to cover. Okay. So that being said, let me think of the data models required for this service. So let me quickly go through this section. So obviously I need the user entity, which has user ID and say, authentication related information or and also I'd like to have the following relationship table. So I would definitely want the follower and followee IDs. Yeah. So this works as the kind of intermediate entity between two users. Yeah. Okay. And also another entity I'd like to have is obviously post entity. So I should have post ID and post it at. This is the timestamp on which Twitter sorted. And also I want to have the tweet sentence contents. Yeah. And also oh yeah, user ID posted by user who posted this post. Okay, yeah. I think these are the things I have to keep. I need for this post table. Okay. So that being said, okay, I will do the data size estimation. Then I will decide which which database should be used for this model. This. Okay. So for data size estimation, so for users, I will assume that there, say let me assume that this service is quite huge and this is 1 billion users. Yeah. Okay. Or maybe 100 million users. Assuming that each user record has 100 byte, it should be 10 gigabyte of record. Yeah. And for follow relations, table, let me assume that one user has on average, say 200 followers. Yeah, I mean, on average, I will assume that one user follows 200 other users. So in this case, the follow relationship record has this many, and then I will assume that each record has 100 bytes of information. Yeah. So in this way, the record should be thinking about times 200. So 2 terabyte. Okay. And for post table, I want it to have, yeah. Basically, this is a bit bigger than other, okay, sorry. So it totally depends how many posts user have made. Yeah, on the right from basis. But let me assume that one user posts 1,000 tweet in his life. No. Then, because each tweet has 140 characters, if this is a single byte characters, it should have 140 bytes. And if, say, this is the Twitter, say 140 unibytes, or yeah, is Unicode characters. In that case, it takes more spaces. So I will assume that each record has 1 kilobyte. So in this way, I'd say, so in this way, this should be 100. 1K, so 100, yeah, terabyte. Okay. But that being said, I think most of the old tweets are rarely accessed. So I think I can think of the ways to say splitting this post table, yeah, in a say horizontal manner. So, but yeah, but let me think of it first after selecting the data store. And one thing I don't want to forget is user can post images in the post. So I will assume that each picture has 100 megabytes. So that being said, I will assume that basically out of 100 tweets, 1 picture is attached. I will assume this ratio. So in this way, I can assume that this number should be, this should be 10, 1 gigabyte. So 1 gigabyte and 1 terabyte, 100 petabyte. Yeah, so this is quite huge. Okay. So now I've estimated the data size of the basic data entities. So I will choose the database for this. So I think these can be stored in the relational database aside from images. And for images, probably I would choose object storage. Yeah, for images, like S3. Because yeah, image is a 100 petabyte, which is quite large. And yeah, definitely should be put on the object storage, which can store, I mean, quite much data. and accessible in a quite performant way. And for user and follower relations and post, in terms of the, I mean, kind of, yeah, because basically I would say I'd like to join the, say, user and follower relationships or user and post models quite frequently, because say if I'd like to show the follower page, list of followers page, I'd like to, yeah. Oh wait. Oh, in that case, I just have to, I mean, I just have to. Okay, so in the, say, definitely what I have in my mind is that in the followers list page, probably it should have something like this user is followed by how many of your following users or something like that. So that kind of relationship should be fetched, or yeah, fetched by the join operation in the RDB quite performantly. So I think RDB is good in that sense. Yeah. And also data size is not big. Yeah. Even though it seems like 100 terabyte is quite big. Yeah, actually this is the, kind of, my understanding is that 100 terabyte is the upper limit of the relational database. Because for example, AWS Aurora can store up to 100 terabyte of data. Yeah. So in that case, in that way, I think this is still acceptable. And also, as I quickly introduced before, tweets, older tweets doesn't have to be fetched frequently. So yeah, maybe they can be stored in the other, say, cold storage or something. Yeah. Or yeah, maybe I should store them in the, instead of that, I should partition the post table by, say, the tweeted year. Yeah. I think it is still acceptable, I think. Yeah. So say, yeah, that being said, if the tweet table is partitioned into 10, it's split into 10, each table has 110 terabyte, yeah, which is much smaller. Okay. Yeah, so I will now do the, yeah, system design, I mean, high level architecture. So, okay. In this system, there is two kinds of readers. Okay, let me, yeah, separate two users I'm thinking of. So one user is kind of the writer who posts the, yeah. Oh, sorry. Let me do one more thing before going on to the system design. So I will quickly do the API design of this. So for post tweet, it should be something like this. So yeah, I will choose the post method and I will say v1 post endpoint is good for this. Yeah, sense pricing. And for getting the, feed, or yeah, I will focus on the feed feature. So I will think how I can get the rated tweet, probably the endpoint that we'll be hitting is like this. So tweet post, and then probably I need the range of the date. So yeah, user ID can be fetched from the authentication information. So what I need is something like that. Yeah. And time is blah blah blah. Yeah. So I think this is quite, I mean, this date range is quite variable when I think of the Twitter feed. So when the front end kind of automatically reloads the new tweet, what I can do is say, yeah, getting the post tweets which was generated after the latest reload until the current time. So in that sense, I think this, yeah, date range is, yeah, kind of quite required. But yeah, oh, but maybe I should have talked about one more option. Maybe this tweet or reloading can be the WebSocket. Yeah. But let me go with the assumptions that, okay, yeah, let me go with the assumptions that front end does kind of regularly do the short polling from the backend and fetches the latest recalls every 10 seconds. Yeah, so in this system design, I will go with that. Okay. Let me quickly write it down. So polling every 10 seconds. Okay. So let me add one thing. So yeah, I chose short polling in this system design because frequency to updates tweet is quite, say every 10 seconds. So it's not so frequent. Yeah. But when it comes to say the chatting app, it has to update the chat page, say every 1 second or every 0.5 seconds to make it near real time. So for the purpose, if I'm developing the web chat, chatting messaging app, I would probably choose a WebSocket here. But I think, for this Twitter app, yeah, it requests every 10 seconds. So I think this is acceptable, I think. Okay. Okay, so that being said, I will work on the system design part. So let me start with the user, which is, yeah, as I said, I have two main users here. The first one is the user who posts the tweet. Yeah. So when the user posts the, okay, so Wait a minute, so. Okay. So when user posts something, wait a minute. Okay, so when the user posts something, what happens is that, so firstly, this should, I mean, or just the front end, yeah. The front end makes a request, it should go to the, say, load balancer, and this should be routed into multiple web server, yeah, like Nginx. Then this should be requested to the application server. So if the what is requested is only the static data, static pages, probably web server is fine. But if it has the kind of dynamic content, it should be handled by application server. And what I can do from here is the user posts the tweet, it should be pushing, I mean, written into the relational database. Okay, and for relational database, I will take the single writer node and multiple read replicas. Yeah. So because what is expected is, I mean, eventual consistency, asynchronous, update is fine for the replication. Yeah. So that being said, which I think, so I mean, I introduced the read replicas because the first reason is the performance for the read operation, or I should say the scalability of the read, operations for the database. And also this is for the durability. So because the data is replicated, so yeah, I mean, this works as the kind of backup of the records posted by the users. So that being said, this is the kind of flow when user makes a request. Okay, and also for the scalability, probably what I can do is introduce auto scaling for this web server layer and application server layer independently. Yeah, and also this read replica. Maybe this can be auto scale. Oh no, read replica. Yeah, I will configure enough number. Okay. So with that being said, yeah, when the user posts the create a new post, it is pushed into the, I mean, written into the relational database. And when the another user, say the follower of this user, opens the post, so what happens is that this makes the request to the load balancer. Oh, probably this is the same load balancer, but let me just, separate them so that I can explain easily. So yeah, this makes the request to web server and application server, and this fetches reads from the, read replicas to fetch the data, and the request is response. Yeah, response is returned to the user. But that being said, this is a kind of problem. So yeah, the problem here is that if, I mean, this read replica operation load is quite heavy. Oh, but wait, I forgot to say something important. So I also have to think of the object storage. So there should be S3 bucket here. Yeah. And if the, say, user makes a post request to post the image, probably what I can do is return the S3. I mean, firstly, the tweet is sent to the server side, and the internally, this creates the S3, I mean, kind of S3 upload endpoint and returns it to the user frontend. And then the frontend should directly upload the image to S3. Yeah. So this is one thing I can do to upload the images. And probably content delivery network should be here inside of the S3. Oh, so sorry. So yeah. If the reader makes a request to get the tweet, yeah, it fetches the image from the S3. But when making a request, this image should be cached in front of the user so that yeah, S3 image should be cached into the global, edge location. So probably the tweet from Japanese user is read by Japanese followers of that person. So this makes sense because images included in the Japanese tweet user is basically fetched by Japanese readers. So yeah, that kind of geological, I mean, location for caching is quite valuable for the caching. And it makes sense, I think. Okay. Yeah, okay, that being said, so the problem of this architecture is that there is the quite heavy load on the read request when showing the feed of the post. So actually this can be the bottleneck. So read requests from read replicas. Yeah. So yeah, so if the read replicas say if if the heavy, when I say it's a heavy load, if it can be handled by say up to 10 read replicas, it okay that I just have to, increase the number of read replicas. However, in the case of Twitter, so my understanding is that read replica has to be quite so many if I'd like to handle that, read query heavy load with just read replicas. So that being said, I have to think of the, overall better architecture for, the newsfeed. So for that, okay, the problem here is that when the new post is created, it just inserts the record into the relational database. So it does a quite rare thing to be done. However, when fetching the tweet post, it has to do the quite heavy join operation. So one thing I come up with is doing some more thing in when the post is created and do fewer little things, less thing when fetching the feed. Yeah, so that's my idea. So let me tell you the idea I have. So when user creates the approach here is that each user has a kind of queue, or I should say, collection of, collection of tweets which should be shown on the post. I mean, shown on the feed of his post page. I mean, home page. Yeah. So when okay. Yeah. When a followed user makes a tweet request, the new created tweet should be pushed into the queue, kind of queue. Yeah, or I should say added to the collection. Yeah. So that's my idea I come up. Yeah. So it writes the recoding to the, oh wait. So, yeah, I think what I can do is, okay, instead of this approach, probably what I can do is firstly, this write operation just puts the new tweet into the, you know, queue of new post, and the worker should subscribe the tweet from this. Then it pushes the, I mean, tweet recalls to the, yeah, queue of the each user, kind of queue of each users. So say if there is another user who follows the same person, yeah, they should also write the tweet into here. This. And also my understanding is that this worker should do the write operations as RDB, which works as the backup. Yeah. So I don't wanna, I mean, Rico's is a queue to be the single source of truth. So I also put the newly created tweet into the relational database. Yeah. So that being said, if the user, I mean, if this user, say, if this user B tries to reload the post, reload the feed, this fetches tweet from this queue. Yeah. So as I said, it has to guess the latest records. Yeah. So it probably needs to kind of data range. I mean, filter the tweet to be fetched from this collection. But I think it wouldn't take that much time, you know? Yeah. Okay. So that being said, yeah, I think this is a quite reasonable approach. As I said, when the user creates a post, it should the tweet is written to the asynchronous queue, and the worker fetches the tweet in the queue and write it into the relational database, and also pushes into the kind of correction of tweet to the follower users, each of the follower users. Yeah. Okay. Okay, so that being said, let me call this queue as feed cache. Okay. Yeah. Yep. However, this also has another problem. So let's think that this post user is a kind of celebrity like Ed Sheeran, who has say 1 billion followers. Yeah. In that case, this worker has to do so many things. So it has to push the new tweet record into 1 billion feed cache. So this is quite much. I think, yeah, this worker, in that case, this worker has, I mean, I have to scale this very quite much. Yeah, so that each record should be each new tweet from the celebrity should be sent to the feed cache in a short time. So instead of this, I will take a kind of hybrid approach. So if the celebrity make a post, it isn't pushing to the feed cache. Let me write it down. So so I would say this is the kind of pool model. So when a celebrity pushes tweet, it is written not pushing to the feed cache. And also for push model, when non-priority tweet, it is pushed to the feed cache. Okay. And when the follower, okay. So yeah, it kind of when the feed is loaded, when or I should say when fetching new feed tweet, it will take fetches from post from feed cache, and also this also post fetch from feed cache and also post, yeah, and also fetches celebrity post from our DB. Yeah. Yeah. So I think this is the kind of possible approach. Yeah. So I think what I can do for this one, I mean, for the last line, I've written that yeah, new feed tweet should be fetched from our DB with the read query. But yeah, and I think what I can do to avoid the kind of resource exhaustion in the relational database we're reading, probably I can do the kind of, sharding with the user ID. So maybe I can do something like, yeah. So only for the tweets from celebrities, yeah, I think it can be stored in kind of one partition with a post table. So that read queries on this post table should not affect other post tables, post records, yeah, queries. Okay. Okay, so I quickly fix the sentences in this text box. Yeah, and okay. Okay, so let me add two more things. Yeah, the first thing is about the caching. So probably what I can do is, oh, okay. So I will talk about two things to reduce the rows on the post table to fetch the celebrities post. So I think what I can do to reduce the load on this celebrities post. So for the first thing I've just come up with is using the putting the cache layer here, maybe Redis or something. And this should have a cache of something like, so range of the say, so like start date, and this is the kind of start and range, and user ID, which is the celebrities ID, to the correction of post. So this kind of cache can be used in front of the post table, especially for celebrities. Yeah. Maybe this start and end should be, 1 sec accuracy. So maybe when front end makes the request to the endpoint, server side, maybe the start date and current date should be rounded up into the second order. So in that way, this caching would work, yeah, fine with start and end date time. Also, what I'd like to add to this structure is, one more thing is, so here I said non-celebrity. Yeah, I think this is fine that this should be fetched for power and sec, per sec, but maybe I can do this kind of celebrity post fetching like every 20 sec or something. In this way, I can reduce the load. Yeah, I think basically tweet from my close friend should be fetched earlier for user experience. Yeah, but I've never mind for in my case, I've never minded if the celebrities post was loaded 10-second radius. So I think this is a kind of possible approach, which doesn't compromise the user experience so much, I think. Okay, and the last thing I'd like to talk about is, so yeah. Okay, one more thing I think I can do is, if there is a kind of non-active user of the Twitter, probably this feed cache isn't necessary, maybe. Yeah. Maybe when this user opens the page, all the recent post should be shown in the feed should be fetched from the relational database. And then at the moment, yeah, this worker should kind of know that this non-active user is now opening the Twitter. So this feed cache should be created for that non-negative, non-active revival user, I think. So I think that is another kind of hybrid approach. Yeah, in another dimension. Yeah. Okay. So that being said, let me finish my system design practice. So as a quick overview, quick summary, I did the Twitter feed design in this video. So I started with the function requirements, then non-function requirements, and Then I created, design the data models. So basically I focus on the, newsfeed, feed features. So only three models, user and relations and post. Then I did the data estimation and found that the relational database is fine for this system design, aside from image in the object storage. Then I did the API design for the, should be good. Yeah, for the, important endpoints. Yeah, one of the highlight here is including the start time and end time to, fetch the, latest post. Then I dived into the system design. Higher architecture. Yeah, and in this architecture, I took the kind of hybrid approach. Yeah, so according to the person who posted the tweet is celebrity or no celebrity, it uses the feed cache, or maybe it doesn't use the feed cache and just write into the RDB. Okay. So let me call it a day today. So thank you so much for watching. So bye.